Hello everyone, I am Balaji K. I am going to explain in this video about process capability in CNC machines. Let's see. These are the learning outcomes. What is process capability? What are the uses of process capability? And how to find out the process capability? And how to calculate CP and CPK values in Excel sheet. Before going to know about process capability, we have to know what is a processor. A process has been defined as a sequence of interdependent procedures, operations or steps that consume resources and convert the input to the output. Listen carefully. Here a input is converted into output by the means of a process, or a process converts the input to the output. So the process plays a main role to convert the input to the output. So knowing about the capability of the process is an important parameter to ensure the quality of the product. So we are checking the capability of the process. So why we are checking is variation arises in the processes which can be measured, monitored, reduced and controlled. We are going to use process capability to measure, monitor, reduce and control the process. We already know process capability is a statistical measurement of process ability to produce parts within specified limits. For example, a company which buys a new CNC machine, they are installing some process in the machine. How they can ensure that the process they install in the machine is capable? So here the process capability plays a major role. Process capability predicts the quality of the manufacturing process that is being fit for use in production. The index CP provides a measure of potential process capability, that is how well a process can perform if there is no change in the underlying process conditions. So we are going to predict the machine's capacity, that is the quality of the output that is going to give out. Now a quick recap. Process capability is a statistical tool which is used for process prediction and monitoring. By using process capability, we can reduce the process variations. If we follow the process capability, there will be continuous improvement. There will be improving the quality, improving in the efficiency. So there will be no loss because of the quality is improved. There will be no rejection. So there is cost reduction. And also there is no need of rework, rejection, reinspection, because we are checking the capability of the process before it fails to give the quality product. So there is no need of rework, rejection and reinspection. That means we don't worry about the outcome of the product. It will be better. We don't need to check again and again if the quality of the product is good. This is the process capability graph. In this this is the process width. This is called as the process width. Here customer gives a limit, that is a tolerance values. These are the tolerance values. That is positive tolerance is called as the upper statistical limit, and the negative tolerance they provided is the lower statistical limit. This is called as the design width. The customer who provides the tolerance limit, this is called as the design width. But we are not going to take the design width as the critical values, but we are taking values in between these two values as upper critical limit and lower critical limit for our process in the company. So this will be the tolerance values for us, but the actual design tolerance values USL and LSL, but we are taking UCL and LCL as our consideration as the tolerance limit. If the voice of the process is within these two limits, the process is capable. If it comes out of the process, the process is capable but not sufficient to produce the quality product. If in the sense it also comes out of the USL and LSL, means the process is not capable and not have the ability to produce a quality product. So these are the difference between the process width and the design width. Design width is provided by the customer and process width is we take as the critical limit on ourselves to ensure the quality of the output products. There will be two parameters which we can use to find the process capability. They are CP and CPK. These are the two through which we can find the capability of the processor. CP is the process capability ratio and is calculated by CP is equal to USL minus LSL by 6 sigma. Here sigma is the standard deviation. By entering the values in the formula or equation, we can get the CP value, and CPK is called as process capability index. It is calculated using CPK equal to minimum of USL minus mean by 3 sigma or mean minus LSL by 3 sigma. Minimum of these two values will be CPK. Now, how we are going to find out the process capability with these two values, and what does the values tell us? We are going to see. CP. The CP index is calculated using specification limit and standard deviation only. To find out the capability CP, we are using specification limit USL, LSL and standard deviation sigma only. But in the case of CPK, we are using specification limit, mean and standard deviation. We are using 3 parameters to find out the CPK values, but in the case of CP, only 2 needed. And also it indicates that whether the process is capable of producing products to the specification only. But in the case of CPK indicates whether the process is capable of producing within the specification limit or not, and also it indicates the ability of the process to adhere to the target specification. Here the target specification is our future aim to produce the quality products as the output. So it also defines the ability of the process to adhere to the target specification. Now consider a process of CNC turning of a shaft. Now we are provided with a mild steel shaft of 25 mm. We are going to turn at one side and to 23 mm. Tolerance provided by the customer is 23 plus or minus 0.4 mm. So our positive tolerance will be 23.4 mm and negative tolerance will be 22.6 mm. We are taking our positive tolerance as upper specification limit and negative tolerance as lower specification limit. And also they provided number of shaft needed per day is 500 shaft per day. Now let us look into the process, how we are going to measure the process capability and CP and CPK values for this process. To find out the CP and CPK values for this process, we are going to make a practical observation, like a sample practical observation. Step 1, diameter data collection of 5 shafts in equal interval of time of 2 hours. We are continuing a process. In the process, we are going to collect the diameter data of the machined shaft for 5 shafts in equal intervals of 2 hours. 2 hours once we are going to check 5 shaft the diameter and the tabulation of the collected data and insert the data into the Excel sheet for the calculation of CP and CPK values. And then finally we are going to generate the distribution plot in the QL macros version of the Excel sheet, through which we can define the process with. Now we after finding out the CP and CPK values, what does they really tell us? If our CPK or CP value is less than 0.67, if our CP value is less than 0.67 means the process is not capable and poor processor. If the CP is between 0.67 and 1 means the process is not capable and not also inadequate, and is also inadequate. And if the process CP value is between 1 and 1.33, here the process is capable but somewhat of producing a high variation but capable process. And if the value is between 1.33 and 1.67, the process is capable and satisfactory. If the value is between 1.67 and 2, the process is excellent and capable of producing good outputs on a large quantity for a large time. And if the value is equals to The process is super excellent and the high quality condition is achieved through the process. The process is fully capable. And for the CPK values, if the CPK value is equals to CP, the process is placed exactly at the center of the specification limits. The process is centered. We are going to look out our workout sample. Let's see. Consider our turning shaft. We are going to turn the shaft to 25 to 23 mm at one side. The tolerance provided is 23 plus or minus 0.4 mm, and USL is 23.4 and LSL is 22.6. Number of shaft needed is 500 per day. Now we are going to look at a practical example of the calculations. Let's see. This is the shaft diameter data. We are taking for 5 shaft. These are the 5 shaft values, 5 shaft diameter values, and taking at equal intervals of 2 hours. So we are taking 8 values per day. These are the values. We are we are calculating mean, we are calculating range, and the standard deviation we also calculated in the Excel sheet. We are using this data and find out the CP value as 1.81 and CPK value as 1.69. What does these values infer? We again go back to the slides. Here we got CP value as 1.81. Here we got our CP value as 1.81 and CPK value as 1.69. If our CP value is between 1.67 and 2, the process is capable and excellent. So our process is capable and excellent of providing outputs. And if CPK value is 1.69, if CPK value is greater than or equal to 1.6, the process is very satisfactory. So our process is very satisfactory. We can calculate CP and CPK values by using the formula. There is another way to find out the capability of the process, that is plotting method. We are going to see plotting method. This is the diameter data. These are the diameter data of the shaft for 40 shaft, continuous shaft. We are going to plot this data in a graph. So we are going to select, this is the data we got, and this is the UCL, and this is the LCL 23.4 and 22.6. Now in Excel sheet, open your Excel sheet and select the data with the UCL and LCL. Now scroll down and select all the values and then click on to insert and plot line graph. Now we got our plot. Now we can see that this is the UCL, the red color line is the UCL and the green line is the LCL. Our process is in between the these two limits, specification limit, and this is continuously improving. Like the distance increases, the process slightly improves and then somewhat decreases and then improves. This is the continuous improvement of the process. The slight changing is indicates the continuous improvement of the process, reducing the variations. Our graph is in between this limit, so the process is capable and adequate of manufacturing.